The National Electrical Code requires that wall ovens be protected by circuits rated not less than the maximum demand load for the appliance. The NEC provides a formula for calculating the circuit ampacity for wall ovens. The formula is ampacity equals demand load divided by 80%. The demand load for a wall oven is determined by its wattage rating. In the example, the wall oven is rated at 3.6 kilowatts. To convert kilowatts to watts, multiply 3.6 kilowatts by 1000, which equals 3600 watts. To calculate the circuit ampacity, use the formula ampacity equals 3600 watts divided by 80%, which equals 45 amps. Based on the calculated ampacity, the minimum breaker size required is 50 amps. The 3-hour continuous usage rule does not apply to wall ovens. This rule only applies to appliances that operate continuously for more than 3 hours, such as water heaters and air conditioners. Therefore, the correct breaker size for the 3.6 kilowatt wall oven is 50 amps. Using a 25 amp breaker would be inadequate and would violate National Electrical Code requirements. Let's delve into the specifics of calculating the appropriate breaker size for a wall oven, referencing relevant sections of the National Electrical Code to provide a comprehensive understanding. Firstly, it's crucial to understand that electrical installations must adhere to the NEC to ensure safety and prevent hazards. The NEC provides guidelines for sizing conductors and overcurrent protection devices, such as circuit breakers, based on the load they are intended to serve. Secondly, when determining the breaker size for a wall oven, several factors come into play, including the oven's power rating in watts or kilowatts, the voltage of the electrical supply, and any applicable demand factors or directing adjustments. The nameplate on the appliance typically provides the power rating, which represents the maximum power the oven can draw under normal operating conditions. The calculation begins with determining the oven's current draw in amps. This is achieved using the formula power equals voltage times current, or P equals volts times amps. Rearranging the formula to solve for current, we get current equals power divided by voltage, or amps equals watts divided by volts. For a 3.6 kilowatt oven operating on a 240 volt circuit, the calculation would be as follows. Firstly, convert kilowatts to watts. 3.6 kilowatts times 1000 equals 3600 watts. Secondly, apply the formula amps equals watts divided by volts. Amps equals 3600 watts divided by 240 volts, which equals 15 amps. This calculation provides the base current draw of the oven. However, the NEC requires that overcurrent protection devices be sized to accommodate the continuous load plus an additional margin for safety and potential overload conditions. Section 210.19 A1 of the NEC addresses the rating of branch circuit conductors and specifies that the conductors shall have an ampacity not less than 125% of the continuous load. This requirement is intended to prevent the conductors from overheating due to prolonged operation at or near their maximum rated current. Similarly, Section 210.20 addresses the rating of overcurrent protection devices and states that the overcurrent protection shall be sized no less than 125% of the continuous load. In the case of a wall oven, which is considered a continuous load, this 125% factor must be applied to the calculated current draw to determine the minimum allowable ampacity of the circuit breaker. Applying the 125% factor to the 15 amp current draw, we get 15 amps times 1.25 equals 18.75 amps. This means that the circuit breaker must be rated for at least 18.75 amps. However, standard circuit breaker sizes are typically available in increments of 15, 20, 25, 30, 40, 50, and 60 amps. Therefore, the next larger standard size breaker must be selected. In this case, the next larger standard size breaker is 20 amps. While a 20 amp breaker would technically meet the minimum requirement of 18.75 amps, it is important to consider other factors that may affect the breaker size. One such factor is the potential for nuisance tripping. If the oven's actual current draw is close to the breaker's rating, even minor fluctuations in voltage or load can cause the breaker to trip unnecessarily. To avoid nuisance tripping, it is often advisable to select a breaker size that is slightly larger than the minimum requirement. Another consideration is the presence of other appliances or loads on the same circuit. If the wall oven is sharing a circuit with other devices, the total load on the circuit must be calculated to ensure that the breaker is adequately sized. The NEC provides specific guidelines for calculating the total load on a circuit, taking into account the demand factors for various types of appliances and equipment. In some cases, it may be necessary to install a dedicated circuit for the wall oven to avoid overloading the existing circuitry. Furthermore, it's important to consider the type of overcurrent protection device being used. Circuit breakers are available in different types, each with its own characteristics and limitations. Standard thermal magnetic circuit breakers are commonly used in residential applications, but other types, such as electronic trip circuit breakers, may be more suitable for certain applications. The type of breaker should be selected based on the specific requirements of the installation and the characteristics of the load being served. In summary, determining the appropriate breaker size for a wall oven involves several steps. Firstly, calculate the oven's current draw in amps using the formula amps equals watts divided by volts. Secondly, apply the 125% factor to the calculated current to determine the minimum allowable opacity of the circuit breaker. Thirdly, select the next larger standard size breaker, taking into account the potential for nuisance tripping and the presence of other loads on the same circuit. Fourthly, consider the type of overcurrent protection device being used and select a breaker that is appropriate for the application. By following these steps and adhering to the guidelines of the National Electrical Code, you can ensure that the wall oven is properly protected and that the electrical installation is safe and reliable. In the scenario presented, the initial assessment suggested a 25 amp breaker, which was based on an 80% rating calculation. However, this approach overlooks the fundamental requirement of sizing the breaker to at least 125% of the continuous load, as mandated by the NEC. The NEC doesn't allow for applying both the 80% rating and the 125% uprating simultaneously. The 80% rule typically applies to the ampacity of conductors in specific situations, not directly to the sizing of the breaker for continuous loads. Therefore, the more accurate approach involves calculating the current draw based on the oven's wattage and voltage, applying the 125% factor for continuous loads, and then selecting the appropriate standard breaker size. Using the example of a 3.6 kilowatt oven on a 240 volt circuit, firstly, convert kilowatts to watts. 3.6 kilowatts times 1000 equals 3600 watts. Secondly, calculate the current draw amps equals 3600 watts divided by 240 volts, which equals 15 amps. Thirdly, apply the 125% factor. 15 amps times 1.25 equals 18.75 amps. Fourthly, select the next standard breaker size, which would be 20 amps. However, considering the potential for nuisance tripping and the recommendations for a margin of safety, a 25 amp breaker might be a more practical choice in some situations. It's also crucial to consult the oven's manufacturer specifications, as they may provide specific recommendations for breaker sizing that supersede the general NEC guidelines. Some manufacturers may specify a larger breaker size to accommodate the oven's startup current or other operational characteristics. In summary, the correct approach to sizing the breaker for a wall oven involves a careful consideration of the NEC requirements, the oven's electrical characteristics, and the manufacturer's recommendations. While a 25 amp breaker might seem adequate based on a simplified calculation, a more thorough analysis that incorporates the 125% factor and the potential for nuisance tripping may lead to a different conclusion. Always prioritize safety and adherence to the NEC when making electrical installation decisions. Let's explore the nuances of applying the National Electrical Code to wall oven installations with a specific focus on breaker sizing and continuous load considerations. The NEC serves as the cornerstone of electrical safety, providing detailed guidelines for ensuring the safe and reliable operation of electrical systems. Understanding the relevant sections of the NEC is paramount for anyone involved in electrical work. from licensed electricians to homeowners undertaking DIY projects. Wall ovens, as major appliances with significant power consumption, require careful attention to detail when it comes to circuit design and overcurrent protection. As previously discussed, the NEC mandates that overcurrent protection devices, such as circuit breakers, be sized to accommodate the continuous load plus an additional margin for safety. This requirement is intended to prevent overheating of conductors and equipment, reducing the risk of fire and electrical hazards. The continuous load is defined as a load that operates for 3 hours or more continuously. While wall ovens may not always operate continuously for 3 hours, they are typically considered continuous loads due to their potential for extended use. Therefore, the 125% factor must be applied to the calculated current draw when determining the appropriate breaker size. The calculation of the current draw is relatively straightforward, involving the oven's wattage and voltage. However, it's essential to use the correct values and to account for any voltage variations or fluctuations that may occur in the electrical system. The nameplate on the appliance typically provides the necessary information, but it's always a good idea to verify the voltage at the receptacle to ensure accurate calculations. Once the current draw has been calculated, the 125% factor is applied to determine the minimum allowable ampacity of the circuit breaker. As mentioned earlier, standard circuit breaker sizes are available in increments of 15, 20, 25, 30, 40, 50, and 60 amps. The next larger standard size breaker must be selected to provide adequate protection. In some cases, it may be necessary to use a larger breaker size than the minimum requirement to avoid nuisance tripping. Nuisance tripping occurs when the breaker trips unnecessarily due to minor fluctuations in voltage or load. This can be caused by a variety of factors, including voltage sags, harmonic distortion, and motor starting currents. To minimize the risk of nuisance tripping, it is often advisable to select a breaker size that is slightly larger than the minimum requirement. Another factor to consider is the ambient temperature in the vicinity of the circuit breaker. Circuit breakers are designed to operate within a specific temperature range, and their performance can be affected by extreme temperatures. If the breaker is located in a hot or cold environment, it may be necessary to direct its ampacity to compensate for the temperature effects. The NEC provides tables and guidelines for directing circuit breakers based on ambient temperature. In addition to breaker sizing, it's also important to ensure that the conductors serving the wall oven are adequately sized. The conductors must have an ampacity that is equal to or greater than the rating of the circuit breaker. Undersized conductors can overheat and pose a fire hazard. The NEC provides tables for determining the ampacity of conductors based on their size, insulation type, and installation method. The installation method refers to how the conductors are run, such as in conduit, cable, or free air. Different installation methods have different ampacity ratings due to variations in heat dissipation. It's also important to ensure that the conductors are properly terminated at the circuit breaker and the receptacle. Loose or corroded connections can create resistance and cause overheating. All connections should be cleaned tight and properly torqued to ensure a reliable electrical connection. Furthermore, the NEC requires that all electrical work be performed in a neat and workmanlike manner. This means that all wiring should be properly supported, protected, and labeled. The wiring should be free from kinks, bends, and sharp edges that could damage the insulation. All boxes and enclosures should be securely mounted and properly grounded. In summary, installing a wall oven requires careful attention to detail and adherence to the National Electrical Code. Breaker sizing, conductor sizing, and proper installation techniques are all critical for ensuring the safe and reliable operation of the appliance. By following the guidelines of the NEC and consulting with a qualified electrician, you can ensure that the wall oven is properly protected and that the electrical installation is safe and compliant. Let's elaborate on the specific NEC sections that are most relevant to wall oven installations, providing a deeper dive into the code requirements and their practical implications. Section 210.19, Branch Circuit Requirements, covers the requirements for branch circuit serving various types of loads, including appliances. This section specifies the minimum ampacity requirements for branch circuit conductors, taking into account the type of load being served and the potential for continuous operation. As previously mentioned, the conductors must have an ampacity that is equal to or greater than 125% of the continuous load. Section 210.20 Overcurrent protection addresses the requirements for overcurrent protection devices, such as circuit breakers and fuses. This section specifies the maximum allowable ampacity of the overcurrent protection device based on the ampacity of the branch circuit conductors and the type of load being served. The overcurrent protection device must be sized to protect the conductors from overloads and short circuits. Section 220.10 General provides guidelines for calculating the branch circuit, feeder, and service loads for various types of occupancies. This section includes tables and formulas for determining the demand factors for different types of appliances and equipment. Demand factors are used to reduce the calculated load based on the assumption that not all appliances will be operating at their maximum rated power simultaneously. Section 220.18 Appliance Load Calculation provides specific guidance for calculating the load for appliances, including wall ovens. This section specifies the minimum load requirements for appliances, taking into account the wattage rating and the potential for continuous operation. The load calculation must be performed in accordance with the NEC guidelines to ensure that the branch circuit, feeder, and service are adequately sized. Section 250 Grounding and Bonding covers the requirements for grounding and bonding electrical systems. Grounding and bonding are essential for protecting people and equipment from electrical shock and fire hazards. The grounding system must be properly installed and maintained to ensure that fault currents are safely conducted back to the source. Section 300 Wiring Methods covers the general requirements for wiring methods, including the type of conductors, cables, and raceways that are permitted. This section specifies the installation requirements for different types of wiring methods, taking into account the environmental conditions and the potential for physical damage. The wiring method must be selected and installed in accordance with the NEC guidelines to ensure that the electrical system is safe and reliable. Section 422 Appliances covers the specific requirements for appliances, including wall ovens. This section addresses the installation, wiring, and overcurrent protection requirements for appliances, taking into account their unique characteristics and potential hazards. The appliance must be installed in accordance with the manufacturer's instructions and the NEC guidelines to ensure that it is safe and properly functioning. In addition to these specific NEC sections, it's also important to consult other relevant sections of the code that may apply to wall oven installations. These sections may include those related to wiring methods, grounding and bonding, overcurrent protection, and appliance installation. By thoroughly understanding and applying the NEC guidelines, you can ensure that wall oven installations are safe, reliable, and compliant with the applicable codes and regulations.